So we're going to start talking about radical functions today. Specifically in our class, we are going to do square roots and cube roots. But any kind of root is a radical function. So if you're referencing my posters, we're on the radical function one. So you can have two separate radicals. You could have a square root one, or you could have a cube root one. Or even or odd. Think of it that way. For the square roots, let's fill this table out. What is the square root of 16? 4. What's the square root of 9?
3.
What's the square root of 4?
2.
Do we know the square root of 2?
No.
Not off the top of my head. What's the square root of 1?
1.
What's the square root of 0?
0.
What is the square root of negative 1?
1. Oh, no, imaginary.
It's imaginary. There's not really a square root of it. And so because we're talking about the graphs, we're talking about like actual real numbers, I don't care about the i's. So for here, we're just going to put undefined and undefined.
For all negatives?
For all negatives, yep. So I'm not concerned about the i's anymore for right now.
I thought 2 doesn't have a square root.
Not a perfect one. It's a decimal. All right, so for the 2, if you want to figure out what that root is, I know it's going to be somewhere between 1 and 2, right? Because that just makes sense for the line. But if you want to figure out the exact square root of 2 is 1.4. So about 1.4. Okay, so now I'm going to graph these numbers 0, 0, 1, 1, 4, 2, 9, 3, and then 16, 4 is off my graph, so I'm not going to graph that one. All right, when you draw your line, you need to be careful. This side does not get an arrow because your table stops at 0, and your graph is going to stop at 0. So your graph is going from 0 all the way that way. So when we're talking about those even radicals, the square roots, it's like an arrow pointed one way. So one side of the graph is just a point. The other side is going to have the arrow.
We're not supposed to put on a number?
If you want to, you can. All right, for the domain and range. For the domain, how far left am I going? No, wait, nope, not infinity.
Stop at 0.
You stop at 0. So we're going to go all the way left to this point. Is it a bracket or a parentheses?
It's a bracket.
Why do you know it's a bracket? Because it's a point, you stop. And then how far right are we going? Yes. For the range, you go down all the way to 0, bracket or parentheses. And then how far up? Infinity. Very good. What do you mean? No. It depends on what your graph looks like. What's up?
Do they always start from 0, 0?
Not once you start translating them. So if you're talking about the parent, yes. But when we start going left, right, up, down, all those good things, then no. All right, cube root functions. We haven't really talked much about cube roots. The first thing, especially those of you that write big and loopy, you need to be really careful. If you write your cube root like this, that is wrong. Because this is a coefficient. It's a big guy out in front. This is saying 3 times the square root. The cube root is a 3 that goes inside the little pocket of your radical sign. So when you are writing cube roots, make sure your 3 goes inside your pocket. Otherwise, you are telling me that 3 is a coefficient and I have to count it wrong, even though I think I know what you're talking about. So the 3 is going to go inside the pocket. All right, now how you get the cube roots in the calculator. I think we all know that square roots are the yellow button and then this guy right here. I know it's kind of hard to see on the board here, but in yellow there's like the square root, right? You see it on your calculator? Okay. The cube root, it's going to be right next door. And so if you can see on your calculator, it has a little n and then a root. Do y'all see that? All right, so if you yellow button and then click this guy, you should get a little box with the root and then another box. And so then that way we can put 3 up here to signify cube root. All right, so I'm going to do it one more time. Oops. So yellow button, and then the cube root is this guy right here, right next to where the square root is. And then that gives you where you can plug in the 3 to signify cube root. And then if I want to start filling out the table, I'm going to put -8 in there.
How do you do undefined?
With square roots you do. All right, so cube root of -8 is telling me that it's a -2. So can you take a cube root of a negative number?
No. Yeah.
Yes.
Because it's negative times negative times negative.
Right. So you can take a cube root of a negative number. You cannot take a square root of a negative number. So that's the difference there. Cube is odd.
So would the opposite on the 8 would be -2?
Yep. The reason why this works is because cube is 3, right? If I take -2 and I multiply it by itself 3 times, I get 3 negatives, which ends up being a negative number. Does that make sense? So that's why it works for the odd guys. All right, so then cube root of -4 is going to be a decimal, about 1.6, -1.6. What do you think the cube root of -1 is going to be?
Positive 1. Negative 1.
Yes. Hi, Anaya. What's the balloon for?
I got my braces off.
Oh, yay!
No,
Does it feel weird and slimy? Yeah, I bet it does.
I got my retainer on. Do I need to charge it?
Yeah. All right, cube root of 0? 0. Cube root of +1? Cube root of +4? +1.6. Cube root of 8? 2. And the cube root of 10 is going to be 2.2-ish. So you'd have to do that in the calculator. All right, so notice on your table, if you're taking a cube root of a negative number, your answer is going to be negative. If you take a cube root of a positive number, your answer is going to be positives. So they match up, the signs. Does that make sense? So it makes it nice and easy. Signs match up. All right, so I'm going to go down here. I'm going to graph it. So I'm going to start with 0, 0. I'm going to graph 1, 1. And I'm going to graph 8, 2. Do what?
Why are you just graphing a random number?
I'm graphing the whole ones. 0,
Oh.
0, 1, 1, 8, 2.
What about the negatives?
I'm going to do that too. Yeah. -1, -1, and -8, -2. So you should be getting the sideways S shape.
The only ones that graph the whole
Isn't that
I mean, you can graph the decimals if you want. It's just hard to estimate. What's up, 7? All right, so are we good graphing that? For domain, how far left do I go? All the way, so -infinity. How far right? Regular infinity. For the range, how far down? -infinity. And how far up? Infinity. Very good.
I looked at a asymptote she used to do it. I thought the y is this way. How did you get offended?
It's going to go down really slowly, but it is still going down. So there's no asymptote bounding it.
How's the domain infinity?
Domain is left and right, so it's going left and down. And this one's going right and up. All right, so remember, anything with like an S or a curvy shape, your domain and range are going to be negative infinity to infinity. The only time that you are going to have it stop with it has to have an asymptote if it looks like this. And I know cube roots don't have asymptotes. The only 3 functions that have asymptotes are rational, exponential, log. Those last 3 are the ones that have asymptotes. So even though it looks like it's not really going up, it is slightly going up forever and ever, and this one is slightly going down forever and ever. So if you expanded your graph out, it would eventually go down forever. It would take a long time, but it would go down because there's no boundary. All right, so are we good with the 2 parent functions, square root, cube root? All right, we're going to talk more about graphing them tomorrow. All right, so we'll do the back with the graphing tomorrow.
Wait, what?
No. We're going to do the transformations today. So all that's left today are we're just going to go over those transformations. It should be pretty much a review, though, because we did these transformations with absolute values and we did them with quadratics. So should be a review. First of all, the vertex, which once again we'll talk more about tomorrow, is going to be the C and the D value still. C value, switch the sign.
But you said this should be reviewed for us?
Should be, yeah.
So you're saying we should have already learned this?
This year. We did it this year. It'll start coming back. All right, so we're going to talk about the A, the C, and the D. Once again, we're not going to worry about the B value here in front of the X. All right, we're just going to do A, C, and D. So, if A is bigger than 1, do you remember what it's called? Very good, a stretch. So if A is bigger than 1, we are going to have a vertical stretch.
How do you know if it's vertical?
It's if it's outside, it's vertical. So the A will always be vertical.
Isn't a vertical stretch like the same thing as like a horizontal?
Yeah.
So if it's less than 1, it's a stretch.
If it's bigger than 1. All right, so some examples of stretches. 3 is bigger than 1. 5 is bigger than 1. -2. Now the negative is a whole translation all on its own.
Isn't that a flip?
Yes. So I'm going to talk about that here in just 1 second. And the 2 is a stretch still. All right, so even though it's negative, you don't worry about the negative sign. You just look at the number. The 2 is bigger than 1, so it is a stretch. Now, the negative sign, what were y'all telling me that it does?
Flip.
What's the math term for flip?
Reflect.
Reflect. Very good. So down here, where we're talking about when A is negative, that's going to be reflecting. The word reflect. So anytime your A is negative, it's a reflection. That's a translation all on its own. Because you can reflect it and stretch it. So the negative will reflect it, the number will stretch or compress it. Does that make sense? So the last one, if it's between 0 and 1, what kind of translation? Compress. And what will those numbers look like?
1/2.
Yeah, 1/2 or 0.25, decimals or fractions. 3/4. Decimals or fractions that are less than 1. I think the A value is probably the hardest. So, number bigger than 1, stretch. Number between 0 and 1, like a decimal or a fraction, compression. And if it has a negative sign, that's a reflection all on its own. The C value. Do you remember what the C value does? What kind of, left and right. Very good. If it's a minus C, which way is it going?
Right.
Right. Because it's backwards. And then the plus C is going left. So inside stuff is backwards, so you got to think opposite when it's on the inside. All right, and then the last translation. Steven, you paying attention?
Oh, that's down.
Up and down. Which one is up?
Plus is up.
Plus is up.
And negative down.
Negative's down. All right. Go to C and D. So C and D, all we're doing is describing the translation, and then D, we're going to go backwards. So, number 1.
That's it.
What is the negative sign?
That is a reflection.
Reflect.
That's a reflect, vertical stretch.
Okay, so reflect, vertical stretch,
Left 5.
Left 5,
left 5,
up 2.
and up 2. All right, so every little piece gets a translation. So negative is a reflect, the 2 in front is a vertical stretch, the plus 5 on the inside of your root is going to be left 5, and the plus 2 on the outside of your root is going to be up 2. All right, take a quick second and try number 2 on your own, and then it's just describing the transformations, and then I will call on you.
Does it change because of that 3?
No, the 3 is not a translation. That's just telling me I have a cube root now, because we're kind of mushing together square and cube root. So this 3, it's not a translation. You just ignore it. Yeah, it's like having the absolute value bars or having the squared. All right, that's all that 3 is.
So much better when they work.
They just like kind of rub it all over the people.
Hey, miss, it's the sign, right?
Is it the regular right?
All right, so Luis, tell me, what does the 1/2 do? Vertical what? Very good, vertical compression. Neil, what does the -2 do?
Right 2.
Right 2. And then Francisco, what does the -3 do?
Down.
Down 3.
Why does it go in the reverse?
What are you talking about?
Like the -2.
Why is this going in reverse?
Yeah.
Why is this, like, because it's minus, it's right? Because in your original function, there's already a minus sign, and so you get a double negative.
Ah, that makes it positive.
Yeah. Okay, almost done. We just got this part here, D, where we are going to go backwards. I'm telling you the transformations, and you are going to write the function. All right, so in my function here, I have the square root of x, because that's what it's telling me, and I just have to put the numbers in. So, reflected in the x-axis. It's going to be negative. Where's the negative going to go?
At the front,
Very front.
so that'll be -1/4.
So, reflected is the negative sign in front. Now it says compressed vertically by 1/4. Where is that going?
At the front.
In the front, right after the negative. And then it says down 2. Where is that going?
Outside.
On the outside. In the back,
2.
-2. Is there anything on the inside? Nope. So I don't really have anything. There's really no need to make your root that long, but. All right, let's try the next one. Left 3, inside or outside? Inside. Is it going to be a +3 or a -3? +3. And then down 1, inside or outside? Outside. Is it going to go in the front or the back? The back. Is it going to be a +1 or a -1? -1 because you're going down. And then don't forget your cube root here because it tells me my function is a cube root. All right. One more. Yeah, you want to do this one on your own? Go for it. Yep. You lost your x. So right after the root, there's going to be an x. So x minus 1 and plus 1. Alright, so I'm kind of seeing everybody's, I think, is getting the right answer. Tell me what I'm going to write. 3 square root
X minus 1
x minus 1
plus 2.
plus 2. Very good.